Okay, so we are doing week 7, and week 7 is another week with linked lists. We already talked about linked lists, we talked about circular lists, we talked about stacks and queues, we talked about bag, and now we're going to talk about double linked, double-ended linked lists, and that is going to help us implement a priority queue. And priority queue is basically a queue where you don't always insert things at the end, and order of things matters. So it's basically insert in order. That's why I gave that a couple of times for the insert in order assignment, because that's basically how we're going to make a priority queue. We're going to insert things in a specific order. And it ties with a lot of these other things that we've done already. The insert after current, those kind of things. So first of all, what is a double linked, double-ended list? Well, you're seeing it, right? So we have a pointer to the first link, we have a pointer to the last link. First and last themselves are links, and then now each of these links, they have two fields. One is next, one is previous, and now we can link with the link that was before it also, right? So we don't only just link forward, we can link backward, and that allows us to traverse the link forward and backward. Okay, we can jump to the first, we can jump to the last, but if we still, if we wanted to go to a specific link in this linked list, we still have to traverse them in order. There's no way for us to just jump to a specific one like we would with an array. So that's basically all there is. And the priority queue part is we're going to link these things, we're going to insert the links in a specific order. Okay? So let's have a look at what I have for here. Queue lists. Okay. Okay, so first of all, this is a queue list from the textbook. And what do we have? We have insert last. How does it work if the link is empty? How you work if there is just one link? How it works if there's more than one links? Okay, and just like with all the other ones, what I would recommend is draw out the pictures. If you don't draw the pictures, you're going to have a hard time visualizing these. Okay, so I guess you have a first last list, right, which is going to have two links. One is first, one is last, and this is what each of these links is going to look like, right? You're going to have some kind of a data, and you're also going to have not just next, but you're also going to have a previous. Okay, so not sure why I have only next in this particular case. Okay, so what happens when you insert a new link in this queue list? Okay, so actually no, this is not a double linked queue, it's just a queue list, right? So there's no previous and next. It's a double-ended linked list because in a queue we're interested in the first and the last, right? So those are some of the things that are important for a queue. And that's why when we're going to make a linked list from this thing, you want to have a first and a last. So inserting a new link, just the usual stuff, right? You make a new link. This is my new link, right? There it is, link 1. It's equal to 20 by default. When there hasn't been anything in the list yet, then the first and last are both going to be equal to that first link, right? So that's just what it ends with being as. Now, second one is we're going to insert another link, and this time it's going to be 40, right? So if we zoom in on this, that's my link 40. Okay, second link. And then the next thing that you're going to do is, so if first dot next is equal to null, first dot next or last dot next well, first that next is going to be equal to null when we have just a single link, which is what we have right here on top. Okay, so if it is equal to null, we only have one link, so we're going to say first that next is equal to new link, right? So basically we're establishing this connection. Okay, so first also known as, or link 1 also known as first, also known as last, is going to be linked to link 2. That is what happens when you do first that next is equal to new link, and then last is equal to new link. Okay, so then at that point last is equal to this one. First remains as equal to link 1, and last is being changed to be equal to link 2. So this is if we have two links. Okay, so at the end of this transaction, this is what it looks like. This is your link 1, this is your link 2. Link 1 links to link 2, and link 1 is equal to first, and link 2 is equal to last. Okay, so that's that one. The next one is we're going to insert another link, and now we're going to the final else, which is right here at the bottom. Right, so this is some other link now. Third link, or once we have more than two links, we're inserting a 60, which is this link right here. So this is the first thing we make. This is what it was originally, right? We had one link and another link. They're connected. This is the new link that we made. The next thing we do is we're saying last.next is equal to new link. Okay, so last next is equal to new link, so we're connecting link 2. Since link 2 and last are both equal to the same thing, when I say last.next is equal to new link, we're updating link 2 as well, right? So we have link 1 is equal to also first, which links to link 2, which links to link 3 now. That's the next thing we did. Okay, so that's this line. And then the next one is last is equal to new link. Now all we're doing is we're just saying, okay, well now last is just moved to this position right here. So first is equal to link 1, which links to link 2 links to link 3, which is also equal to last at this point. Okay, and since this is not a circular list, since it's not a double-ended list or whatever, mainly since it's not a circular list, then this thing ends with a null. Okay, and that's that one. And just in case you want it, there's another one. Right, let's say we want to insert another link. We're inserting an 80. This is my new link now. Link is 80. Okay, the original thing was we have link 1 is equal to first, which links to link 2, which links to link 3, also known as last. Okay, and then again, last.next is equal to new link. That means we're updating these two right here. Link 3 and last at the same time are equal to link 4. Right, so we established this connection, and the next thing to do is you're saying last is equal to a new link. Okay, so basically you're just moving last from link 3 to link 4, and there you go. Okay, any questions? So the idea is we're always inserting in this queue list. The last link that we're inserting always goes all the way to the right. Okay.
That's only for like one queue in which one direction.
Yes. So this is a single linked queue. That is why when we looked at these links here on the top, it only has a next, right? If we had a double linked queue, then it will have another link that goes towards the previous link. Okay. So this is a queue list, and again, what we do is for inserting links, we always insert all the way at the end. Okay, so this is the implementation of the queue abstract data type using the linked list data structure. Okay, we already saw how to do it with an array, and now you know how to do insert with that. Okay, insert and a queue list. Okay, and then again, this is in chapter 4 of LA4. You can look through the more details about this queue list. The next thing is double-linked, double-ended queue, and that's what you're going to need for this project 1, right? For the project 1, you're going to have to do a double-linked, double-ended priority queue using linked lists, right? And if you can do that, I am confident you have understood how to do linked lists, right? If you can figure out how to insert and delete and insert in order and keep track of all these separate different connections and links, you got linked lists. Okay, so double linked, double ended queue. Okay, so first of all, let's see what I have in here. You have the following two classes. You have a link class, right? And that thing has a data item or field, and it has two links. One is next, one is previous. Okay, the actual double link, double-ended queue, and by the way, I am not following the official Java rules. My classes should start with capital letters, right? So I'm kind of messing up here. Not that it makes a difference as far as syntax is concerned, but the convention is all classes should be uppercases. Okay, so this is the double link, double-ended queue class, and what does that thing have? Well, it has two links of itself. One is going to refer to the first link, and the other one is going to refer to the last link. Okay, and that's basically it. So in here, what I have is an example of a double link, double-ended queue with three links, right? So you have link 1, link 2, link 3. First is equal to this link 1. Last is equal to link 3. And you can see the relationship of these different links. For the first link, the next field for the first link is equal to the next link over, or link 2 I call it. But the previous field is equal to no. So the first link's previous is equal to no, just like your last link's next is equal to no. Okay, and that's how we know we have gone through the entire list. If you're starting at the back of the list and you can basically say, let's say we have current is equal to last, right? If you wanted to go forward, you're telling it current is equal to current previous. If you want to go one more forward, you're saying current is equal to current previous. Okay, so that's how you move, and then when you get to no, you can't move any further. That's where you end it. If you're going forward through the list, you make, let's say, current is equal to the link 1 or the first. You move forward by just like we've been doing so far. You're just saying current is equal to current dot next. Okay, then you go to link 2. You say current is equal to current dot next. That moves you to link 3, and then there's no more next. You got to the no, and then you got to the end of the linked list. Okay, so that's a double-ended double link queue. And I guess jumping straight to the assignment, and using the example program that's in the book. This is inside your LaFour will show you a double-ended double linked queue. Okay, so using that example program, what you have to do is you have to create one that's show queue. Okay, which just shows the queue, and it looks like it's a priority queue. Okay, so we're assuming it's a priority queue. So show queue, you can do a show forward or show backwards. You can show the queue in this order if you want, or you can start backwards from the last one and show it that way too. So you can do that, but just for this assignment, just do it in one direction. You need to do an insert first left, so that means that we're going to be inserting all the way to the left. And again, the assumption is the thing has already been sorted. If you're going to be doing a priority queue, it's already been sorted, and what you're going to be inserting to the first left has to be smaller than the previous thing that was all the way to the left. Okay, insert first right. Again, the assumption for a priority queue is the thing has already been sorted. So what you have to do is you have to look for where this value is supposed to be inserted. So let's say you start all the way at the left. You're going to move one down, you're going to move one down, you're going to look for any value that's less than, or any value that is greater than the value that you're trying to insert. If no value is greater than the one you're trying to insert, then your value is going to go all the way to the right. Okay, that is if you're trying to find how to do it, insert in order. Okay, these here, insert first left and insert first right. Right? They don't have to go and check to see if the value that you're trying to insert is less than any of these other ones. It's assumed that if you're going to be inserting on the first left, then this value is going to be less than all the other values. And it's assumed that if you're going to be inserting on the first right, then your value that you're trying to insert is greater than all the other values. And what you're going to do is you're actually going to use these two methods here to help you insert an order, right? If your value happens to be less than all the other values, call this method, right? If your value that you're trying to insert is greater than all the other values, call this method. Otherwise, insert in a specific order. Okay, and how are you going to insert in a specific order? Well, you start at the first, you can start at the last, but let's say we start at the first. You're going to move forward until the value that you're trying to insert is no longer greater than the value, right? So let's say, is 6 greater than negative 200? Yes. Is 6 greater than negative 100? Yes. Is 6 greater than 5? Yes. Is 6 greater than 10? No. Stop right here and insert at the one before it. Okay? Since you're dealing with double-linked, double-ended queues, or especially since you're dealing with a double-linked queue, you no longer have to be so concerned about, oh, current has to be one up from where I'm trying to insert, because you can always tell it, okay, we'll go backwards one and insert before the previous one. Okay, it might help you to have two links. One is current and the other one is previous, if you want to like maybe keep track of this stuff easier in your head, but it really isn't necessary. Okay, I might actually create an extra link just to make it easier for me. Remove first left, remove first right, right? That's why it's a double-ended queue, because you can remove left and right. It doesn't have to be just from one side. And in addition to this, we also do a remove link, which is similar to what you've done already, except the difference now is that since you're going to have links to previous and next, you have to figure out how you're going to reestablish these links so that it doesn't just break the whole thing. Okay? And that's basically it. So this is double-linked, double-ended queue. That is your project, the culminating experience for the linked lists chapter. Okay, so we're revisiting stacks and queues, implementations with lists. Go through the chapter, read through those, and we're implementing in particular double-linked, double-ended priority queue using linked lists. Okay, so you're gonna do that. That's project 1. Okay, and I also have a solution for that, so you can look at that thing, but do that only if you get stuck. Any questions?
So priority queue is the one that you already have. You insert in order.
Priority queue is a queue where you insert in order.
Okay,
Yeah.
so you don't have to short the number of the classes on
What do you mean?
like we have to insert it or something like that? Or find the value, we have to short.
For a regular queue, you always insert on one side, and you always remove from one side. So let's say if we're gonna insert at the right, you're always gonna remove from the left, right? So in a priority queue, you're assuming a sorted list, and then you have to go and find where to insert the value. So the assumption is the list has already been sorted, and then you're going to be inserting in a specific order in that sorted queue.
Okay.
Yeah. And since this is a double-ended queue, that means that you can insert in left and right, and you can also remove left and right. But again, the assumption is you're only going to be inserting in the left the values that are, all the smallest value, and you're going to be inserting all the way on the right the biggest value, because it's a sorted queue. That's just the assumption for the priority queue. Okay.
Wait, so if you want to insert smaller value, you have to use the one to the left.
Yes. So if you're looking at, this is where is it? Insert in order, right? So the insert in order, what you're going to do is you're going to say if So first of all, you're assuming that this, let's say you're assuming that this is a sort. Well, you are assuming that this is a sorted list. So all these values are there already, right? Okay, and suppose you're trying to insert the value of negative 200. Okay, well, negative 200, first thing you want to do is you want to check, okay, is negative 200 less than this value? If it is, then just call insert left, right? So you're going to insert all the way to the left if your value that you're trying to insert is less than all these other ones. Okay? If you go through the whole queue, let's say you're trying to insert the 200, you're basically going through the whole queue. You have gone through the whole queue using this insert in order. You got all the way to the end, right? None of these values were less than or greater. None of these values were greater than the 200. So you inserted all the way to the right. So that's the purpose of these insert first and then insert left.
So you're using insert right or insert left with the insert in ascending order?
Yes.
So you're calling it inside the...
Yes. I'm using insert first left and insert first right inside the insert ascending order.
So you're calling those methods?
I'm calling those two methods from inside here. But only if I'm going to be inserting all the way to the left and all the way to the right. If I'm not, then you have to go through, the normal course of insert ascending in order is just go through all these different numbers and stop at the first one, which is, bigger than the value that you're trying to insert.
So you have pretty much 3 if statements.
Yeah. Yeah, you have 3 ifs inside the insert ascending order. Yeah. More mental gymnastics. Okay? Yeah. Depends how much you do and on your caloric intake.
It sounds like a quick way to check.
Your brain gets bigger, right?
What's that?
Your brain gets bigger.
Yeah, your brain gets bigger.
It sounds like a quick way to check, and it's just if your number is greater than first, or if your number
If your number is less
than last.
Yes.
You first and last, quick statement, check it.
Exactly. Since it's a good point. Since this is, I totally forgot the part that this is a double-ended queue. So yes, the quick way to do it is you're not going to go through all the elements. You're going to check to see if your value you're trying to insert, is your value less than the value that's first? If so, call insert left. That's what happens here. And if your value is bigger than your last, then insert all the way to the end, calling insert right. Otherwise, figure out, just go through them individually, hop through the different links, and then wherever it goes, the first one that is bigger than your value that you're trying to insert, that's where you're going to insert it, right before that one. Yeah? Any other questions?
It's not circular.
Not a circular list. This is not a circular list. Remember how the last one ends with next is equal to no, and the first one ends with previous is equal to no. And everything else in between is just double linked.
For the methods that we have to write,
Yes.
usually you tell us to return a Boolean or return the link that we delete.
These are, I think these are all void.
Don't return anything.
Yeah, just remove it. Yeah, these are all void.
Sometimes it's useful to return something because you can print it, or I don't know. It's a little bit
You could
more-
return if you want. That's fine. Yeah.
Or just we can.
It's up to you.
return
As long as you can. I mean, show Q obviously shouldn't return anything. Insert first left shouldn't return anything. Insert first right shouldn't return anything, unless, well, yeah, they shouldn't return anything. Insert in order shouldn't return anything. Sure, because this is a list that expands itself. You should always be able to insert unless you inserted a billion things and you crash the computer, right? Remove first left. I guess maybe you can have that return true or false if you can remove a left, or I guess if it's not empty, you return true, but you don't have to, right? Remove first right, same deal. Remove link, same deal. If you find a value, remove it. Otherwise, don't. You can either return true or false, but that's optional.
So that's kind of all void.
Yeah, you can have them all as void. I mean, the only one that kind of makes sense to see if you could remove a link is maybe this one here. Maybe return true if you could remove that particular link. Return false otherwise, but you don't have to. All right, let's just assume there's a link in there and you can remove it. As long as you can do that, I'm happy. Okay, the main thing for me is for you to know how to reestablish these new connections if you're inserting something or if you're deleting something.
Wait, so for remove link, you have to make sure that the left or the right connected and you remove them, right?
Yes. So when you're
and the key will go there.
yeah, if I'm removing this link here, then I have to tell this previous link, instead of linking to link 2, link to link 3. If I'm removing link 2, I have to tell link 3, okay, you're no longer linking to previous. Previous is no longer link 2, previous is link 1. So those are the two connections you have to reestablish. If you're deleting, you have to tell this is going to be link 3, and you have to tell this one here it's going to be link 2. Right? If you're going to be deleting this one, well, then that's a different story. All you have to do is tell it this one here, the previous link, next is going to be equal to no, right? If you're deleting the last one, far right. If you're deleting the first one, then the only thing you have to do is basically just tell link 2 that previous is just null. That's it. Okay? So yeah, deleting the one in the middle, and that's why I would recommend doing the remove first, remove last, insert first, insert last, because that's going to take care of maybe like a third of the problem for insert an order and delete or remove a link for you. Okay?
How about display?
That is the show queue.
Show. Oh, there.
Yeah, we have a display, show queue. And for this, you can tell it to show the queue and forward, start at the first, go to the last. And you can also maybe do another one, call it show reverse, where you start at the last one and then work your way back. Go previous, previous, previous until you get to the beginning of it. Okay? Questions?
Yeah, on the first assignment, we have to type up what's in section 5.4 and test it. Usually you tell us, oh, and add these methods on top of it. Do we need to do any of that or just actually just copy it?
5.4? Was this 5.4?
The assignment number is 9.
Number 9, yeah. It just says type.
Oh, assignment number 9. Oops, sorry, I totally skipped that one. Assignment number 9. This one is with a link stack. Test the program using link stack app. Submit your tests. Yeah, I guess I have to figure out how to add something to it. Yeah, maybe not. But maybe it will be something else like have the user type a word or something and reverse it in order or something like that. Maybe. No. Okay, well that's why I have it simple. Because
It says copy it and run it.
pretty much, yeah, get it to
I
work.
like it as is.
Okay, you like it as is. I'll have like an optional
I'll
extra
put it on
credit.
the project.
All right.
Extra
Well,
credits for
extra credit if you use this to,
We had to do the reverse or something.
Yeah.
Or something, right?
yeah. Or maybe I'll figure something else too, like check to see if the parentheses in an equation are matching, like the way your compiler checks. If you want.
well, you have to read the
Extra credit. Extra torture, extra credit. Okay, so that's in a nutshell what is
So this assignment here is the same as what we did before, that stack, except it's instead of using an array,
yes.
it's using links.
Yep, this is similar to that other stack assignment, except actually,
Do you have to put like rear and then front?
yeah, this one has a rear and a front. Where's the stack one? See if I change something to it. Stack. I don't know if I modified it. Yeah, I did. I modified it. So some people had already finished it without doing this, and I gave them credit. But yeah, I added a little something to this. Is basically have the user enter a sentence and then show that in reverse using the stack. Maybe we can do something like that for this, or maybe what I can do is have you, check to see if the parentheses on an equation are balanced, that kind of stuff. Maybe. Okay. So yeah, we're pretty much halfway through the semester. Any questions?
Do we have final?
Do you have a final? You don't have a final, unless you insist. I will give you a final if you want one.
And no midterm, right?
No midterm. This will be your midterm. That project, we'll call that a midterm. Yeah.
You do a project in your university was
Which one?
when you go to college. You do a project, right?
Yeah.
USC.
Huh? Yeah.
USC? Yeah.
Yeah. Yep. Well, yeah. So these programs that we're doing, they're very.
It's very simple.
They're much simpler than what you would encounter in, when you go to university, and it depends on which university you go, but especially if you go to the top ones, yeah, you're going to be like, welcome to Berkeley or whatever. Here's the 20,000 lines of code and figure it out, and now add whatever.
20,000.
Yeah, that was my experience at USC. It was just basically, welcome to software, Principles of Software Development. Here's a program we already have. There's this project with 20,000 lines. It's a restaurant, and we have customers, and we have cooks, and we have all kinds of different things happening, multi-threaded. We want you to add a waiter. And there's these rules, like if a customer has been there for so many minutes, the waiter goes there and this and that, serves them. And yeah, it was a monster project. It was like 20,000 lines of code. 20,000, yeah.
You have to copy paste it.
You get all the stuff.
Oh, you get the
You
whole
get all the
stuff.
stuff. You just have to figure out how the whole thing works using the Java docs and all that good stuff.
But you're gonna have to take like some courses stuff before you take that.
That was my first class.
That was your first.
That was my first class when I transferred, yeah.
What is it called?
It was like Principles of Software Development or something, like software engineering. I can't remember what it was called, something like that. It didn't sound very hard. It was like, oh, that's shouldn't be too bad. I am really good at programming. I got this. And then it was like, hit the wall, instantly hit the wall. Yeah.
Individual project, not a partnership.
Well,